Hi guys, and welcome again to Module 2, Create a Cryptocurrency. So, in the previous tutorial we just got started with all the different libraries we had to install and to import. So that's a good thing done. We are now going to start our implementation in 3 parts. Part 1, building the blockchain. Part 2, mining the blockchain. And Part 3, decentralizing our blockchain. And so in the next 3 tutorials we're going to add what's needed to be added in our blockchain class to transform this general purpose blockchain into a cryptocurrency. And so now the question is, what makes a blockchain a cryptocurrency? Well, the answer is transactions. The principle of a cryptocurrency is that we're able to exchange these cryptocurrencies through transactions that are secured, added to new blocks, mined by the miners in the most secured way. That is that once some transactions are added to a new block, the block is integrated to the blockchain and then it's impossible to modify anything in the block. And that's what makes the blockchain revolutionary. That's because all these transactions are registered in a fraudless way without any possibilities of cheating. And so now that we understand that, well, the key element we'll be adding into our blockchain class are these transactions. That's our first pillar, and then the second pillar will be to build a consensus function to make sure that each node in the decentralized network has the same chain. Because once some new transactions are integrated to a new block which is added to the blockchain, well, we need to make sure that all the nodes in the network get also their chain updated with this last mined block containing the transactions. And this particular check is called the consensus. So that's our 2 pillars for the development of this part 1, building a blockchain. First, adding the transactions, and second, making the consensus. So we're going to start with the transactions now. We'll take care of this in this same tutorial, and then in the next 2 tutorials we'll take care of the consensus. Alright, so let's tackle the transactions first. So, where do we need to start exactly? Well, of course, we need to start with the init method, because now the new thing very important to understand is that we need to introduce a separate list which will contain the transactions before they're added to a block. And that's for the simple reason that the transactions are not born in a block. The transactions happen, they're appended to a list one by one, and then as soon as a miner mines a block, well, all the transactions that were accumulated are added to this block. But it's very important to understand that originally the transactions are not into a block. They're added into a block as soon as a block is mined. And that's why right now we need to make a separate list of transactions which will contain any new transaction that happens in the world, and then once a block is mined, all the transactions of the list will get into a block and the list of transactions will become empty, and this empty list will be reused to welcome some new transactions that will be added to a new future block that will be mined a couple of minutes later. That's what happens in real life, and that's what we're going to make right now. Alright, so as we said, the first thing we need to do is to create this separate list of transactions before they're integrated to a block. And so now the next very important thing to understand is where exactly in the init method we need to add this list of transactions. And this location is very important. It's a specific location and it must be before the create block function. This create block function that we call here to create the genesis block. Because if you put this list of transactions right here after the create block function, well, you'll get an error because in the create block function we'll add the transactions here in a new key, and therefore when we call the create block function here, there needs to be the transactions created first. Otherwise, the create block will not know where to look for the transactions. So that's very important to get the right order here with the transactions being created just before we call this create block function in the init method. So there we go. Let's introduce a new variable attached to our object, which will be our list of transactions. Make sure to understand that this is the list containing the transactions before they're added to a block, and we will of course initialize this list as an empty list. Perfect. So that's the first thing done, and now what is the next step? Well, the next step is of course, as we said, to add a new key inside this create block function. And here The order doesn't matter. You can add the transactions wherever you want. The order only matters in this init method. So let's add the transactions in a new key, which we're going to call transactions. And the value of this new key will be, well, all the transactions contained in this transactions list. So we're going to take this transactions list. That's why I'm taking the self here, because this is a variable of the class. And we add here our transactions list. All right? So that way, when we create a block, that is when we call this create block function, well, it will take all the transactions of this list self.transactions. And then, now you're going to understand this even better, because once it takes all the transactions of this list, self.transactions, well, as I said, this list of transactions must become empty, because we add the transactions only once in a block. You cannot have the same transactions in two different blocks. So we need to empty that list now, and that's exactly what I'm doing now by taking my self.transactions list, which I'm updating to the empty list. All right, and that must be, of course, after we add the original transactions into our block. All right, so that was very important to understand. If you get this, well, you're definitely ready to move on to the next step. And what is going to be the next step? Well, the next step now is, of course, to create a certain format for the transactions. That is, a format with a sender, a receiver, and the amount of AddCoins exchanged. And to create this format, we'll make a tool, which will be a function, a new method of this blockchain class, which will not only create this format for the transactions, but also will append this transaction to our list of transactions, again, before they're integrated to the block. So that's exactly what we need to do now. And therefore, I'm going to scroll down because this is going to be a new method. And we're going to call this new method add transaction, because this is going to be a method that will create a transaction between the sender and the receiver exchanging a certain amount of AddCoins, and that will add this transaction to our list of transactions. So now, of course, the question is, which arguments is this add transaction method going to take? Well, for self, of course, we're going to use the variables of our blockchain class. And then very simply, the other arguments will be the keys, that is the key elements of a transaction. And these are, as we just said, the sender, the receiver, and the amount of AddCoins exchanged. That's our 4 arguments. And now we are ready to define what this function has to do. So to be efficient, what we'll directly do is take our list of transactions containing the transactions before they're added to the block. Forgive me for insisting on this, but that's very important to get it. So we take this list of transactions and we're directly going to use the append function to append a new transaction. And speaking of this new transaction, we're going to define its format right now, thanks to our 3 arguments here, which will be exactly the keys of this transaction, because this transaction will actually be a dictionary containing the 3 following keys: the sender, the receiver, and the amount. And these arguments here will be, of course, the values going with these keys. So in the future, when we call this add transaction method, well, we will actually input the real sender, the real receiver, and the real amount of AddCoins exchanged. All right, so let's do this. Let's input our 3 keys and our 3 values, which are the arguments. So the first key is our sender, which will get the value our sender argument. Great. Then the next key is the receiver, which will get the value our receiver argument. And finally, the third and last key will be the amount of AddCoins exchanged, which will get the value the amount argument. There we go. We just defined the format of a transaction in a dictionary containing those 3 keys. And now the only thing that we have to do left is to return something that will be very practical to return, which is the index of the block that will receive these transactions. When the miner mines new block, the transactions will go into this new block, and what we're about to return right now is the index of this new block that will get these transactions. And so now the question is, how can we get this new block? Well, very simply, we simply need to get the index of the last block of the chain, but this last block of the chain is already a fixed block that can no longer receive any transactions. So these transactions will actually go in a block that will have the next index, and therefore it will be the index of this last block plus 1. And that's exactly what we need to take now. So let's do it this way in 2 lines. We're first going to get the previous block. So just introducing a new variable. Now, how are we going to get this previous block? Well, good news, we have a function that will give us that directly. It's the get previous block method. So I'm just copying this. Previous block equals, then we need to get self because get previous block is a method of our class, and then just some parentheses. So that gives us exactly the previous block. And now we are going to return the index of this new block that will welcome these transactions, which is the index of the previous block. And to get this index, we just need to get the key, the index key of this previous block, and then we add a plus 1, because of course this new block will have the next index after the last block of our chain. So there you go, we're done with the first pillar of our cryptocurrency, taking care of the transactions, and now in the next tutorial we'll take care of the second pillar, which will be the consensus.